So I have a basic question for you. How did generations of people learn math using slide rules, and none of them ever noticed that it's impossible to define exponentiation without using 1 as the initial reference point? That fact is literally the reason that slide rules even work, right? They were used regularly from their invention in 1962 up to the 1980s, and they're still used to some degree now. If we take a generation to refer to roughly 25 years, which is probably longer than is average, that means they were used for over 14 generations. Right? So this is a conservative estimate here. In that time, nobody noticed that it's wrong to say that 2 to the third is 2 times 2 times 2, despite slide rules literally requiring you to use the correct form of 2 to the third being 1 times 2 times 2 times 2. Fucking how? The relevance being that during those 350 plus years, professional mathematicians settled on the idea that 0 to the 0 is undefinable. However, if you notice that the 1 is always there as your initial reference state, then absolutely everything to the 0 power must be 1. So it's definitely true that nobody put this together. Now, in 1752, Leonhard Euler published a claim that 0 to the 0 equals 1, but his logic is nonsense. Okay? His basic claim is that if 2 squared is 2 times 2, and 2 to the first is 2, then 2 to the 0 is 1 because you divide by 2 each time you decrement the exponent. Or in general terms, if a squared is a times a, and a to the first is a, then a to the 0 is 1 because you divide by a each time you decrement the exponent. And I've seen this explanation given literally everywhere. It's not an explanation, because this utterly fails for a base of 0. Because 0 squared is 0, and 0 to the first is 0, and division by 0 is undefined. So somehow 0 to the first is 0 squared on 0, which is 0, but 0 to the first on 0, which would be 0 to the 0 power, is 0 on 0, and that equals 1. What is this shit? What are you doing? And yet again, this has gone unchallenged for the most part. Whenever you see a challenge to this, it's just kind of everybody's like, throwing up their hands and like, oh, wow, it works the way we've been doing it, so let's just go with that. Right? Euler's analysis is the one which is advocated by the tutoring company that I'm currently working for. It's used by Khan Academy. It shows up on Stack Overflow explanations. It's taught in most textbooks. Pretty much anywhere I've seen an attempted explanation at how exponentiation works, they say what Euler said. Okay? Now, this link here is the link to, it didn't all come through. That's okay. But it is the link to the publication that Leonhard Euler wrote, where he outlines all of this. Right? And note that this was published 130 years after the invention of slide rules. But it gets worse than this, right? Euler's claim that division by 0 yields an infinity is also quite odd, since L'Hopital's rule was published over a decade before Euler was born. Now, there's a detail to this that makes this even worse. Because it's perhaps convenient that Leonhard Euler communicated with and was to some degree mentored by, pretty much he was trained by, Johann Bernoulli. Johann Bernoulli was the individual who developed L'Hopital's rule. But Leonhard Euler did not publish his claim that 0 to the 0 is 1 based on asserting values for 0 on 0 until after Bernoulli died. Okay? If you know anything about L'Hopital's rule, it's about finding values for 0 on 0 under certain conditions. Okay, so Euler's claim that division by 0 yields an infinity contradicts L'Hopital's rule. L'Hopital's rule was developed by the dude that taught Euler math. What in the fuck? And Euler didn't publish this until after Bernoulli died. It's like 3 or 4 years or something. Yeah, so Euler published in 52, Bernoulli died in 48. 1752, 1748. Wow. That seems convenient, okay? Further, Euler's publication makes assertions about 0 on 0 having a specific value, at least whenever convenient to Euler's misguided arguments. But the entire point of L'Hopital's rule is to establish contextualized values for 0 on 0, or infinity on infinity, positive or negative, given that various constraints are met. Or in other words, L'Hopital's rule clearly demonstrates that 0 on 0 cannot be evaluated independently, and further provides a limited ability to evaluate it contextually. On its own, 0 on 0 is utterly meaningless. It is not infinite, as Euler claims some of the time, and it is not 0, as he claims other times, and it is not 1, as he claims in his alleged demonstration that 0 to the 0 is 1. He is correct that 0 to the 0 is 1, but his reasoning is absolute trash. And sadly, everything needed for him to properly sort it out had been established by previous generations. A significant part of it literally by the dude who taught him. Some of the more relevant individuals, he knew directly, right? Like the guy who taught him, Johann Bernoulli. To my mind, this clearly illustrates that Euler was a charlatan. To some degree. I'm not saying that, everything he said was a lie. I'm not saying he's a pathological liar. But I'm saying what he's doing here, whether he was consciously aware of it or not, is clearly a manipulation of his situation. Right? He knows that he can get away with this. At some level, he knows he can get away with this. So he does. Right? There are also other knock-on effects of accepting Euler's claims. For instance, the so-called Archimedean property is taken to apply to all values. It was so named in the 1880s because Otto Stultz mistakenly attributed the concept to Archimedes of Syracuse. However, it appears in Euclid's Elements at the beginning of Book 5 as definition 4. And I'll read the English here. Those magnitudes are said to have a ratio of with respect to one another which, being multiplied, are capable of exceeding one another. Okay. And Archimedes himself is known to have attributed the idea to Eudoxus of Cnidus, whatever the hell, who predates Euclid. Euclid predates Archimedes. Eudoxus predates Euclid. So, Otto Stultz is also definitely full of shit. He might have just not really done any research on this and just been like, he knew that Archimedes said it, and that's it. But, there's other people in the field of mathematics. Like, somebody else should have come along and been like, bro, okay, that's fine. Archimedes did say this, but it's older than that. Have you ever read Euclid? Have you ever heard of Eudoxus? Have you ever read Archimedes? Because Archimedes said Eudoxus came up with this. And that's a few centuries earlier than Archimedes. So why are you attributing it to Archimedes? Anyway, clearly history is not the strong suit of mathematicians here. Right? This is a trend that is revealing itself here. Okay, so this becomes relevant to our analysis of Euler's claims that 1 on 0 is infinite because it brings us into the realm of Cantor normal forms. These are descriptions of infinite values that allow the application of arithmetic to those values. Georg Cantor, to his credit, was adverse to referring to these values as infinite, naming them instead transfinite. But subsequent generations of mathematicians have been much less careful, syncretizing Euler's claims with the result of Cantor's work, yielding paradoxes rooted in pure delusion. Right? For a clearer sense of what I'm talking about here, consider the graph of y equals 1 on x. So at this point, if you've seen my videos, you know that I'm kind of beating this horse to death here. Okay, as x tends toward positive infinity, ignore what's happening near the origin or for negative x. What it appears to be doing is getting closer and closer to the x-axis, approaching a y value of 0, but never quite reaching it. So long as we consider things from this framework, from the point of view of moving from the origin towards infinite x values via arithmetic, the only sorts of values we will ever encounter will be transfinites, or smaller. That is, arithmetic will always apply, and thus the Archimedean property will always hold. That is, regardless of where you find yourself at any point along the journey, you can always go further. Okay? But the problem is that mainstream mathematics just stopped there and asserted that there is nothing more to understand about this. Thus, the Archimedean property is asserted to apply everywhere, all of the time. And as a result, no value has specific neighboring values. That is, there is no value which directly neighbors 0. You can choose any value. I'm going to choose 0. However, it is actually trivial to show that this is an overstatement of the significance of the Archimedean property. Let's go back to y equals 1 on x. But this time let's actually examine what it's doing near the origin. For infinitesimal positive values of x, y tends to positive infinity. For infinitesimal negative values of x, y tends to negative infinity. For x equals 0, y is completely undefinable. None of these things are remotely controversial, and yet somehow nobody's ever published a coherent explanation of what's happening here. If x equals 0 is behaving completely differently from x is greater than 0 and x is less than 0, and x is greater than 0 is behaving differently from x is less than 0, then that tells us that there are literal neighbors to either side of 0, which are subject to different sorts of mathematical manipulation than 0 itself is. That is, there absolutely must be something immediately to the right of 0, and something immediately to the left of 0, with absolutely nothing in between them. Further, the inverse of these values neighboring 0 must themselves be infinite, carrying the sign of the values themselves. Further, the inverse of 0 is not infinite, but rather undefined. And these infinite values are the attractors of the function y equals 1 on x as x approaches 0. What this means is that the inverses of the values neighboring 0 are not ordinals, and as such, you cannot grow them via arithmetic manipulation, which means the Archimedean property does not apply to them. And this whole mess arguably goes back to Euler claiming that 1 on 0 is infinite, which people stupidly just accept because it's Euler.